Okay, B's and G's. This is AP Calculus Summer Review. I am Mr. McColley, and this is SR number 3, Systems of Linear Equations. Let's get right to it. The goals today, we're going to talk about solving systems of linear equations, and we're going to do that in a couple of different ways. And then we are going to use systems of linear equations to model functions. So, let's get to it and talk about what these things are. Now, solving systems of linear equations. Solving systems of linear equations is a process of finding the ordered n-tuple where all of the variables for each equation have the same value. Now, this is fairly easy when we're visualizing equations in 2 variables and 3 variables. 2 variables would give you a line, so you'd have 2 equations and you'd have 2 variables each, and that would create a line. And so the solution of that system of linear equations would be this point right here. All right, now when you're talking about a system of linear equations in 3 variables, that thing is a plane. And so when all 3 of those planes intersect at a point, you will have your solution to that system of linear equations. Now the thing is that three 3 variable systems can intersect in ways that are other than just a single point. So there are some times when you may have no solution. All right, what else do I have here? Oh, those are just my credits. Mrs. Boyd will be proud. All right, so we're going to talk about 3 methods for solving systems of linear equations. There are others. This is going to be the big one that we will be using most often, but I just thought I'd review the algebra here for the other 2, and we'll just do a couple simple ones for that. So first of all, you could do substitution, and substitution is basically solving one of the equations for a single variable and then plug that expression that you get when solved for one of the single variables into the other equation. So basically what I'm going to do here is I'm going to take this first equation and I'm going to solve it for either x or y, and then I'm going to replace the x or y in the second equation with that new equation, and what it's going to do is it's going to cancel out one of the 2 variables, and then we'll have only one variable. And then once we're finished, we go back and we solve for the second variable. So let's get right to that here, and we'll talk about solving this. And it really doesn't make any difference. It's not going to be pretty either way that I do it. So I'm going to take this equation and want to solve it for x. So we'll go 3x plus 2y is equal to -5. All right, so we're solving for x. So I'm going to subtract 2y from both sides. I'll have 3x equals -2y minus 5. And then I have to divide everything by 3. Unfortunately, 3 does not divide 2 or 5 nicely, so we're going to end up with an expression. And that expression is going to be x equals -2y minus 5 all over 3. Now again, this is substitution, so we have to do a substitution, and we must use the second equation. And if you put it back into this original equation, I think everything's just going to cancel out, and you're going to get an error, but we're not real worried about that. So what I'm going to do is I'm taking this second equation here, and I am going to replace the x with this new equation that has y in it. So x is being replaced with -2y minus 5 all over 3. And then I take my -3y equals 14. So the only thing that I've changed here is that, and I don't like that y, so let's change that. All right, so all I've changed here is I've replaced x with this expression that I solved with the first equation, and now my new equation here has nothing but y's in it. So when I solve this expression, I should be able to find just y. All right, so let's do that. Let's distribute my 2. So I've got 2 times -2 is -4y. And you know what? I'm just going to put it over 3 here. And then 2 times -5 will be -10, and that'll still be over 3. And then because I want to combine my like terms, I have 3y here, And so there are 9/3 in 3. So I'm going to go 9/3, and I'll just leave the y on top. That way it matches with that one. And then I have 14. All right, so combine my like terms. Negative 4y and negative 9y is going to be negative 13/3 y. So negative 4/3 y minus 9/3 y gives me negative 13/3 y. I still have my negative 10/3. And I know that my next step is going to be to move this 10/3 over to the other side. So here's what I'm going to do. I'm going to change this 14 into thirds. And for every one, there is 3/3. So I'm just going to go 14 times 3. Well, 10 times 3 is 30. 4 times 3 is 12. So there is 43/3 in 14. No, that's wrong. There are 42/3 in 13. And let me make sure, since I screwed up. 42 divided by 3 is 14. There we go. Okay, so I did it right. So my next step, I'm going to add 10/3 to both sides. All right, so I've got negative 13/3 y. And then I add my 10, so I have 52/3. Now, to get y by itself, I would divide by negative 13/3 on both sides, but since it's a fraction, let's simplify that, and we will multiply both sides by negative 3/13, the reciprocal of that, which is essentially the same process as dividing by negative 13/3. And the good news is that all cancels, and I'm left with just y. And then my 3's cancel here, and so I have 52/13. Well, let's check that one. 52 divided by 13. Hey, that's 4. Awesome. So I got a negative there, so I have to say this is negative 4. Well, that turned out nice, even though the equation was kind of ugly. So now I know what my y is. So now all I have to do is figure out what x is. So I'm going to take this negative 4 and take this equation that finds x. It finds x for us, so why don't we use it? And I'm going to go x equals negative 2 times negative 4 minus 5 all over 3. And negative 4 times negative 2 is going to be positive 8. And 8 minus 5 is 3, and 3/3 is 1. So my final answer for this system of linear equations in two variables is going to be 1, negative 4. Awesome. So if I graph these two linear equations, they would intersect at 1, negative 4. Second method I'm going to talk about is row reduction. And row reduction is a similar process to the one we just did, except what we're going to do is we're going to find the least common multiple of one of the variable coefficients, and then we are going to multiply each equation by a scalar and then add or subtract. I know it says subtract here, but we're going to add or subtract so that one of the variables cancels out. And so what we're going to do is we're going to continue that process until we're left with only one variable. And then once we've solved for that one variable and we get a number, we're going to work our way backwards to get the other variables. So I'm only going to do one in two variables. If we had 3 variables, it takes a little bit of time, but you guys can do it. You can look it up if you ever get stuck with that. If you ever get 3 variables, I suggest you do the matrices, which we're going to do last. But if I look at this thing, I could, and again, we're going to solve by row reduction here. Well, I could cancel out my y's if I wanted to. I could find the least common multiple between 3 and 4, and the least common multiple between 3 and 4 is 12, and so I would multiply this one by 4, this whole equation by 4, and this whole equation by 3, and I get 12s here, and they would cancel out, and I'd be left with just x. But I see that I lead off with a 2 and a 4. Well, 4 is the least common multiple of 2 and 4. So instead of multiplying both equations by a scalar, I only have to multiply this equation by the scalar 2. So here's what I'm going to do. I'm just going to distribute that 2 to every term, and I'm going to put it down underneath here. So 2 times 2x is 4x. 2 times 3y is 6y. And 2 times 2 is 4. Now, because these two values have the same sign, they're both positive, I am going to have to subtract. Now, if they had opposite signs, we could just add. The whole point of this is we're trying to get these x's to cancel out. So 4x and negative 4x, well, those cancel. Or 4x minus 4x cancels out to 0. Negative 4y minus 6x is going to give me negative 10y. And I said that wrong, so let me clarify. Negative 4y minus 6y gives me negative 10y, and then negative 16 minus 4 gives me negative 20, and I wrote that incorrectly, negative 20. All right, then I'm going to divide both sides by negative 10, divide by negative 10, and I get y equals 2. Well, that's awesome. There's my first value. So now I can take either of these two original equations that I have here, and I can make it look a little prettier. If you need to go back, you can always rewind. I can take this 2 and I can plug it into either of these two equations. Well, this has smaller numbers, so I'm going to take my 2x, get a pen, and make my 2x plus 3 times the value that I found there, 2, equal to 2. And now I have 2x plus 6 equals 2. 2x equals negative 4. I get that when I subtract 6 from both sides. And then when I divide both sides by 2, I get x equals negative 2. So my final for this one is just going to be negative 2, 2. And that is the point where those two equations intersect. Now my final method of solving is matrices. So we're going to write each equation in general form. Now that's not different than what we had in the last two. General form, x's and our variables on the left-hand side, constants on the right. If we look at this original one, we got variables on the left-hand side, constants on the right. So that's going to be our general form with all the variables aligned. So a column for the x's, column for the y's, column for the z's, or whatever you have. Then we're going to create a square matrix from all the coefficients from the variables, and then we're going to make a single column matrix from all of the constants. Then we're going to use our calculator and go A inverse B, and then the column that is the result from top to bottom corresponds to the values of the variables from left to right. So basically what that means is you're going to get two matrices. When you go A inverse B, you're going to get a column. So if this is X, Y, and Z column, then the corresponding, so from left to right, we're going to go top to bottom. The result are going to be your X, Y, and Z like that. So that's how you're going to read it. All right, let's try one. So my first one here, it's going to be a 3 by 3. This is my coefficient matrix, which is going to be my A matrix. And I'm going to go 3, 4, 2, 2, negative 1, 3, 1, 3, negative 2. Now remember, it doesn't have a variable, or it doesn't have a coefficient. We assume it to be 1. The other thing, just in case, you may see this sometime, if you have X, Y, and Z in the first one, X, Y, and Z in the second one, but only X, Y in the third one, then you should put a 0 for the Z column in that last one. All right, so now I want to have a constants matrix, and this is going to be my B matrix, and it's going to be 1, 13, negative 11. And so I'm just going to pull up my calculator here, and this one isn't quite as good as the one I used at school. It's an older version, so it may seem a little different as we go through it. So my first matrix, I'm going to go second, and I'm going to hit the inverse button right here. It's a little matrix. And then I'm going to go over to edit. I'm going to hit 1 because that's going to be my A matrix. And what did I screwed that up. Let's clear everything out. Let's go second matrix. Let's go over to edit. I went over 1 too many times, that's why. Hit 1. Now, this is a 3 row by 3 column matrix, so we have to tell it how many rows and how many columns. Then we're going to plug in what we know. 3, first one, 4, oops, I didn't hit it right. 3, enter, 4, enter, 2, enter, 2, enter, -1, enter, 3, enter, 1, enter, 3, enter, -2, and enter. And you can see it starts at the top, goes left to right, and then goes top to bottom, just like you would read a page out of a book. Okay, so we have that one. We've hit enter, and that number is locked in. So I'm going to go second. I'm going to hit matrix again. I'm going to go over to edit one more time. We're going to hit 2. This time we need a matrix for this column matrix here. It has 3 rows, but only has 1 column. And we're going to enter that data. So the first one is a 1, then a 13, and then a -11. Oops, too many. So let's try that again. -11. Hit enter. -11. Delete. Enter. Okay. So we're going to quit out of that, and now we go second, matrix. This time, instead of editing, we're going to stay in names. Going to hit 1. Going to hit that inverse button, second matrix again, hit 2 for B, hit enter, and we can see that our result matrix is, in fact, let's see, it's 1, -2, 3. So A inverse B gives me 1, -2, 3. So our final 3 tuple is going to be, and this is our final answer. What's that? Did I just delete that? There we go. Our final is going to be the ordered 3 tuple, -2, 3. And there we go. All right, last question. This is application, a pizza shop problem, one everybody loves from pre-calculus. So 3 families go to a pizza shop where all the drinks and desserts cost the same. Family 1 purchases 3 drinks, 3 pizzas, and 1 dessert at a cost of $22.75. Family 2 purchases 2 drinks, 3 pizzas, and 3 desserts at a cost of $47.50. Family 3, 4 drinks, 4 pizzas, and 4 desserts at $47. What is the cost of a pizza, or a drink, a pizza, and a dessert? Well, right here, these are your variables. So I'm going to call that D, I'm going to call that P, and I'm going to call that T. So I go back up. Family 3 has 3D plus 2P plus 1T, and that gave them $22.75. Family 2 had 2D, 5P, and 2T, and that cost them $47.50. And then family 4 had 4D plus, and I need a plus there, 4P plus 4T, and that cost them $47. So my coefficients matrix will be 3, 2, 1, 2, 5, 2, and 4, 4, 4. And my constants matrix, the column matrix, will be 22.75, 47.50, and 47 even. I don't need to put the decimals for all of those. It doesn't really matter. So again, I'm going to pull up my calculator, and let's move it over here so we can see it. And then what we'll do is, again, second matrix. We'll go over to edit, and since it's already a 3 by 3, we won't change the dimension, so we'll just hit enter. And the first one was 3, so I'm going to hit enter there, and then it's 2, 1, and then 2, 5, and then 2. That should be it. No, should be a 2. Delete, enter. Okay, and then 4, 4, 4. And once I've hit enter and locked that number in, I can go second matrix. I can go over to edit. I can hit 2. Still a 3 by 1, but this time 22.75. 22 22.75. Something's up with my pad. 22.75. There we go. 47.5, and then just 47. So 22.75, 47.5, and 47. Hit quit. And now we can go second. We can go enter like that. And that brings up what we just did. Now, even though when we did it before, it was 1, -2, 3, even though we brought up the same expression, we have updated the matrices. So since the 8 matrices have been updated, it's going to do this calculation on the new matrices, and we'll get that. And so $1.50, $8, and $2.25. So we can say that a drink was $1.25. No, that's wrong. It was $1.50. A pizza was $8, and a dessert was $2.25. I don't know why that keeps doing that, but we'll make it look. And there is my final solution. Okay. 21 minutes. That one's kind of long. Sorry about that, but we are done. And our Star Wars fun fact of the day, Wedge Antilles is the only secondary character to survive all 3 battles in the 3 original Star Wars movie, the Battle of Yavin, the Battle of Hoth, and the Battle of Endor. In fact, he led the X-Wing charge in the Battle of Endor. Well, that's enough. Have a good day. I'm finished. Goodbye.